Hello friends. So in this lecture, I am going to discuss coordinate geometry. My name is Dr. Mukesh Kumar. So before we go for any discussion in detail, we are going to discuss why coordinate geometry is important and what are the applications, why exactly, or what we mean by coordinate geometry. Okay, so that could be covered in the introduction. Then we're going to cover the distance formula. And then after, if time allows, then we can discuss section formula, area of a triangle by using this coordinate geometry. And therefore, we're going to have a summary and examples. So one of the example you can see, which you can notice in your daily life, is the directions. So you know about this, that north, east, west, and south. So this could be represented as a coordinate axis, and one can call this horizontal axis as x-axis and this vertical as y-axis. Okay, and this is the mathematical form, or you can say the geometrical form, which can be described like if you wanted to represent a point on a plane, then you can represent using the coordinate geometry. So we're going to discuss about these figures in detail and how basically the mathematical formulation or algebraic formulation is going to happen to define coordinate geometry. Okay. Now, so let's introduce this. And obviously the question is, what is coordinate geometry? So we can say that coordinate geometry is in fact has been developed as an algebraic tool for studying geometry of figures. That means it helps us to discuss or study geometry using algebra and understand algebra with the help of geometry. So this is the correlation between geometry and algebra, you can say, is defined as a coordinate geometry. So let's understand what are the applications of coordinate geometry. So in physics, you might have seen that when you throw a ball, it follows a path in a plane. Okay, so so this is defined as a projectile motion, and this could be, if you go in higher classes, obviously you're going to see this example very frequently when you learn physics. Okay, similarly in engineering, especially when you talk about the aeroplane or something like which is floating in air, you can see that this coordinate geometry is very much helpful to define the axes and all those stuff. Okay. Similarly, when you do the navigation, obviously you might have familiar with in today's environment, you know about the mapping. When you travel, you generally have a Google search and you see that there are mappings which shows you the directions from one place to another. So these are some of the examples which coordinate geometry should apply for. One of the things is seismology, which is very advanced for your level, but to just having a knowledge, you should know about this. Another application is art. So you might have seen it from very childhood time, that how you draw a cartoon or something in a very kind of a plane, which is described in this mathematical form, and you just join the points and you will get a cartoon on your picture. Okay, so these are some of the applications and definition of coordinate geometry. So to go into more detail in algebraic and representative form, we should know about number line. And you might have known from your previous classes that you represent, or you can say visualize, numbers on a straight line. And this straight line could be horizontal or vertical. As you can see, this is the horizontal number line and this is a vertical line. And then you describe with a origin. And when you go, you can say from right from the origin, then you will see that this is 1, 2, 3, 4 is a positive number. And if you go left through your hand, you will see this is a negative number. So basically, if you go from, if you say this is left, this is right, then from left to right, it should be in an increasing order. Similarly, for vertical, you can have the origin here, And then this is the order from bottom to up, or I mean, it is your convention, which you can fill up always. Either you put the positive number up here, upstairs, or in a downstairs. So it depends how you wanted to choose your vertical numbers. Or so these are the number line which you know about. Now, coordinate geometry is basically mix up of these two, horizontal and vertical number line. Okay, so this includes Cartesian plane, coordinate axis, and origin. Okay, and this I show in a very first slide where I showed you that this figure. So you can see that this horizontal and vertical lines basically coincide at a point which we call it as a origin. Okay, and this horizontal line is called x-axis. We called it abscissa, and this vertical line is called ordinate or y-axis. Okay, and the point can be represented something like this. So the convention to represent this point is, first we have to represent it as x coordinate, comma, y coordinate. Okay, so this is the convention. That means if you wanted to represent this point A as 20 and 15, that means you have to first move from the origin to x-axis 20 and then go to the vertical point till this coordinate matches with the y-axis, so which is 15 here. So the coordinate of point A 20, 15 can be represented like this. Okay, so these are some of the basics which one should know about the coordinate geometry. So one should also note that the Cartesian plane, which contains coordinate axis and origin, also have this 4 equal parts. It is divided in quadrants. Okay, so this is first quadrant, this is second quadrant, this is third, and this is fourth quadrant. So this is very interesting concept. So you can see here that in quadrant 1, all numbers should be positive. That means the x-axis always give you positive number, also y-axis give you positive number with this convention. However, in quadrant 2, your x-axis is negative, so this is negative, and then y-axis is positive, so this is positive. But in third quadrant, both numbers are negative. So x is negative, y is also negative. Similarly, in quadrant 4, you can see that x-axis is positive, okay, and then the y-axis is negative. So this is the convention that one should follow, and these are some basics where one should know about the quadrants as well. Okay, hope this is very clear to you. So let's do this one example, and then you can pause the video and you can draw these following points on a coordinate axis, and you can understand how to actually represent the point in a plane. Okay, so let me do that. So what you have to do, you first have to have this kind of axis. You can say the Cartesian plane, which we defined just in a previous slide, and then represent this number. So this is called origin. So this is 0, 0. Similarly, 2, 0. So you can see x is 2, y is 0. So this could be somewhere here. Okay. Similarly, 0, 3. So 0 means x is 0 and x0 is here, but y is 3 around this. So you can put this number like here. So similarly, you can go through and check that 2, 3 is here, minus 3, 0 is 0, minus 4, 5, minus 5, minus 5, 3 minus 3 can be represented like these points. Okay. So always remember that first number should be x coordinate, second number should be y coordinate. Okay. One interesting thing you can notice here, that if you match these points, it will give you some kind of shape like a line or a parabola. And this you might have known from your some previous chapters, that a line equation can be represented as ax plus by plus c equal to 0, where a and b simultaneously cannot be 0. Okay, so if you join these 2 points, for example, or 3 points, which is going to coincide with each other, then you can form a straight line. Similarly, you can have a parabola if you can just pull something like this, or from here to here, you can match these numbers and you will get a parabola, but you're going to understand these things in very detail if you go in higher classes. So you can see the definition which we gave before, that coordinate geometry is nothing but it's a connection between geometry and algebra. You can see and visualize from these examples. Okay, so let's go ahead and learn about distance formula. So distance formula is basically, to understand this, we need to just go through one example. So let's suppose given a point P is located 4 kilometer east and 3 kilometer north of a point A. So you have to find the distance AB. What you need to do, obviously, the example which I showed before, that one of the example is the direction. So first of all, you need to have this kind of direction and put things in x-axis and y-axis. And according to this statement, you can obviously see that point A, let's suppose that point A is something here. Okay, so point A is here. So it says that it is located 4 kilometers east. So east, you can see you represent by x-axis. So 4 kilometers. So let's suppose this is kilometers. So 1 kilometer, 2 kilometer, 3 and 4. So this is 4 kilometer you walk, and then 3 kilometer north. So north means this is y-axis. So you can go up. So again, 1 kilometer, 2 kilometer, 3 kilometers. So this is the point which you can say that point A is located. Okay, so according to the problem. So now we need to find the distance AB. Okay, so what you can see that this is nothing but a right angle triangle. Okay, so if you draw like this and just make up this thing, and obviously this line is there. So this is nothing a right angle triangle. So you can always use Pythagoras theorem and find the solution. Okay, so by using Pythagoras theorem, you know that this is and AB is going to give you a base square plus perpendicular square, the square root over there. So this is 4 and this is 3. So you can have a square root of 4 square plus 3 square. And you know that 4 square is 16 and 3 square is 9. So this is going to give you a square root of 25. 25 square root is 5 kilometer. So this way you can find a distance by using Pythagoras theorem. Okay. But the question is, if you have some situation like this, okay, so what are you going to do? So you have first of all, let's do one problem. Okay, then you're going to understand very clearly that if something is arbitrarily given, then how you're going to find. For example, if it is located, origin is fine, origin is given, A and D is given, B and C is given, and someone asks you to find BC. Okay, well, how you can do that? Obviously, so A, you can find that this is 2, 0, B is 2, 3, because you know x-axis is 2, y-axis is 3. So 2, 3. Similarly, C is 4, 4, and D is 4, 0. Okay, what you can do then? You can find a point E, which is located somewhere here by drawing a line from here to here and here to here. Okay, so this line E, this point E is basically 4, 3, because it is 4 x-axis and height is 3. Okay, now this is a right angle triangle, and from here again you can use Pythagoras theorem, and you can find you know, by doing this exercise you can find the distance BC. Okay, so please go through this detail, and before looking at the solution, I always say that pause the video and try to solve this by your own, and then try to understand what I have given here. Okay, now let's move for another exercise. Okay, here point P, Q, R are located in a coordinate axis of Cartesian plane. You have to find the distance PR. Okay, distance PR. So first of all, you can again pause the video and you can see how you can find. However, I'm going to give you the some details, some hints for this problem. So first of all, obviously you need to find the coordinates. Okay, so you are now habituated. So to find the coordinates, so you know that P is pi 4. Similarly, Q is -4, 4, R is -4, -4. Okay, so then you can add this distance, the whole distance PQ, similarly QR and RP. Okay, so you can again use a Pythagoras theorem and find the U. Okay, however, since this is a very simple problem, you always find a right angle triangle and use a Pythagoras theorem. But what could be generalized form of distance formula? So let's try to understand this. Okay, so let's consider some point P of the coordinate x1, y1 is given and x2, y2 is given as Q. Okay, let me move this here. And it says that let's consider the general point P and Q with coordinates shown, find PQ. How you wanted to do this? Okay, so let's do this by ourselves. What you can do, obviously you can draw a perpendicular line from this to x-axis, and you know that this r coordinate is nothing but x1, 0, because y is 0 here on x-axis, and you also know that if you wanted to find x here, so on y-axis always x is going to be 0. That means any coordinate on y-axis is 0, whatever point you wanted to choose. So from here you can see that this point is nothing but 0, y1. Okay, so similarly you can do for point Q, drop a perpendicular line over x-axis. You can find this coordinate as x2, 0. Similarly, this point is nothing but 0, y2. Okay, now you can again draw a parallel line from RS to PT, and this coordinate you can find very easily because x2 is the coordinate of this point. Okay, and you can see that y1 is the distance from here, because you can see from here to here it is x2, so that's why it is x2, and the height is y1, you can see from here, so this is y1. Okay, so again this is a right angle triangle, so just use now Pythagoras theorem, and you can see that PQ is nothing but under square root of PT square plus Q2 square. And what is PT? So PT you can find very easily, because you know from here to here this is x2, and from here to here this is x1. So this distance is nothing but x2 minus x1. Similarly, this distance QT, so QS is y2, okay, and TS is y1. So this distance is simply y2 minus y1. Okay, so just put it there, and when you do this, so this is one of the formula which you can find as a distance formula. Okay, so two remarks you can see from here, that the distance of point pxy from origin 0, 0 is going to give you simply PO equal to root of x square plus y square, because you know that if you put origin here like 0, 0, you can just find x2 square plus y2 square, something like that. Okay, so similarly you can derive that, as you know that any number within the square is going to be positive number, so whether you write x2 minus x1 or x1 minus x2 is going to give you the same number. So you can write PQ as square root of x minus x2 whole square plus y minus y2 whole square as well. Okay, so this is very important distance formula which we're going to use further for all the examples and all the necessary steps. Okay, so similarly, so to use this distance formula, let's do one example. Suppose a point xy is equidistant from point 3, 5 and 7, 2, then find the relation between xy. Okay, so this is the situation. So P is given as, let's suppose 3, 5, and T is given as 7, 2, and Q is lying between them. That means the ratio between PQ and QT is 1:1. This is the midpoint. Okay, so how are you going to do this? So you know this is very simple, that it is given PQ equal to QT, so you can always square it. So PQ square equal to QT square, And you suppose that Q has a coordinate xy, P has 3, 5, and T equal to 7. Use the distance formula. So by using distance formula, you can always write this as this. So you have x minus 3 whole square plus y minus 5 whole square for PQ square. Similarly, this is equal to Q2 square. So Q2 is going to give you x minus 7 whole square plus y minus 2 whole square. Okay, just use the formula. Now expand it and then cancel out all the equations, and you will see that this is the relation between x and y, which is going to give at x minus 6y equal to 19. Okay, so please use this by yourself and try to grasp the knowledge. And if there is a problem, obviously one can discuss it later. However, the situation can be a little typical, and this Q should not be always like 1:1. Okay, that means Q could be here, let's suppose, or here in the ratio m:n. So what one can do then? Okay, so we need to again generalize this. So that's why the second thing which we wanted to learn in this chapter is the section formula. So that we will learn later, but I'm just giving you some hint that how the application of these can be used. Okay, so let's suppose this is m:n. Okay, as shown in the figure. So this is the formula that one has to have if one could have this point internally on this line. But if also there is a situation when this point could be on a line, but not internally cutting down, but it can cut somewhere outside. What one can do that? So one has to find this also. Similarly, if this CXY is not lying on the plane in this line and some place like here, then this could make a triangle. Okay, so can we use the distance formula to find the area of this triangle? Okay, so these are some of the questions that one can learn in the next sections. So we will see you later on these details. So for the time being, thanks, and let me stop here. Thanks.